In this video, we're going to look at the chain rule, doing the derivative using the chain rule. So first we want to look at the decomposition of two functions that have been composed together. We're going to apply the chain rule with the power rule. We're going to apply it with the product and quotient rules. We're going to recognize when the chain rule for a composition of three or more functions should be used, and then we're going to describe the proof of the chain rule. So first we want to talk about the composition of functions that you would have learned in your Calculus 1 class, college algebra, or high school algebra. The composition of functions is when you have a, quote, inner function, and then you have, quote, an outer function. And so we want to think about when we would have done this in pre-calculus, and also at the beginning of this quarter when we started talking about the difference quotient. If we look at the difference quotient, which is f of x plus h minus f of x all over h. This is my difference quotients, which we used something similar to this when we talked about the definition of derivative, or we wanted to know the limit as x approaches a of f of x. We used basically the difference quotient. And so this part, f of x plus h, really is a composition of functions. If I would have said h of x is f of g of x, then my g of x would have been x plus h. And wherever I would have seen x in my original function, I would have replaced it with x plus h. That is a composition of functions. So with our warm-up, what we're asked to do is figure out what would be the best choice for the inner function and what would be the best choice for the outer function. G of x is the inner function, and then f of x is the outer function. The inner function here, you could use x, but it's not going to be helpful, so our inner function typically is the value that's underneath the root symbol. So if it's the square root or the cube root. So g of x would be the ideal candidate for my inner function, which is x squared minus 8. And then my f of x would have been the outer function, which is the cube root of x. If I look at b isn't quite as straightforward. But remember, we don't want g of x to just be x, because then it's really not a composition of functions. However, what I notice is I see this x cubed here in the numerator and here in the denominator. So I'm going to let g of x equal my x cubed. That means my f of x is going to be wherever I see x cubed here or here, I'm just going to replace with x. So I'm going to have just x over x minus 1. And then on C, this last one, it's pretty straightforward. I think it's easier than B. That you can see I see x minus 1 twice. And so I'm going to let my g of x be the x minus 1. That means my f of x is wherever I see x plus 1, I replace back with x. So 2x squared minus 5x plus 7. So we have decomposed these composition of functions. So we want to think about when we're doing the decomposition, what would be the easiest inner function, the easiest outer function without just using x, so that we can do derivatives that look like f of x is equal to x minus 5 to the 6th power, or the sine to the 4th power of 3x. The last thing we're going to want to do is to write out the product rule by writing x minus 5 6 times, nor would we want to write sine 3x 4 times and do the product rule. That is just way too much work. So here we learn the chain rule. Now the chain rule is really important to help us take some of the more difficult derivatives, such as x minus 5 raised to the 6th power, and make them fairly straightforward. Here is how it is defined. So if I have this composition of functions of h of x is equal to the composition of f composed with g of x, or we might say it as f of g of x, then this is the gist of it. H of x, the derivative of h of x, is going to be the derivative of the outer function multiplied by the derivative of the inner function. Alternately, we can choose the inner function to be u. And so I have dy dx is the derivative of y with respect to u and the derivative of u with respect to x. When we're doing the chain rule, what we want to think of this is like the Matryoshka dolls, the Russian nested dolls that are kind of stacked within each other. And you take the derivative of the most outer function, whatever that is, and then you keep going in doing derivatives of the inner functions until you get to the most inner function, wherever that is. So another way you may see this is the y is equal to f, a function of u, fu. So what you want to do is you want to determine who is the most outer function and do the derivative of the most outer function, and let u equal the inner function if you just have two functions. If you have more than two functions, you are composing more than two functions, then it gets a little more interesting, and you can't just say y is equal to fu. You have to put a little bit more into the thought process of going through who is the most inner function. So if you are asked to do the derivative with the power rule, h of x is equal to g of x to the n, then this is really straightforward. It is like we expect with the power rule, the n is going to come down out front. My function g is going to be raised to 1 power less, and then I have to remember to do the derivative of the inner function. So if you remember, we had that f of x is equal to x minus 5 raised to the 6th power. Following this rule, f prime of x would then be, the 6 is going to come down out front as a multiplier, x minus 5 raised to the 5th power. That is this piece of it. So that I've just done the derivative of my outer function. My outer function is something to the 6th power. Now I need to multiply by my inner function derivative. My inner function derivative is x minus 5. So the derivative of x minus 5 is just 1. And so that would be the derivative of x minus 5 raised to the 6th power. Now, what does that mean for trig functions? If I have the sine of g of x, so in other words, I have the sine of something other than x, then it is the cosine of that angle multiplied by the derivative of that angle. And I actually prefer these better because then you can see that I'm doing the derivative of the angle u. So the derivative of sine is cosine u du dx, cosine u tangent, and etc. So if I'm asked to find the derivative of something that's just a simple power function such as this, I can, if I want to, break this down into f and g. And if I want to do that, I can say f of x is my outer function, which is x to the 5th power. And then my g of x is my inner function, which is x cubed plus 3. So y prime would be the derivative of f prime of g of x multiplied by g prime of x. F prime of x is just going to be 5x to the 4th. So this is going to be 5, but my x is actually my inner function, x cubed plus 3. Now it's raised to the 4th power. G prime of x is going to be 3x squared. So then I have to multiply by the 3x squared. So y prime in this case, when I clean this up, is going to be 15x squared x cubed plus 3 raised to the 4th power. Let me do that again with the next one. So I have f of x, which is my outer function. This is x to the 4th. F prime of x would be 4x to the 3rd. G of x would be my inner function, which is 5x squared plus 3. G prime of x is just going to be 10x. So y prime is going to be f prime of g of x multiplied by g prime of x. So y prime is going to be my 4, and it's not x cubed. Remember, this x cubed gets replaced with g of x. So it'd be 4 multiplied by 5x squared plus 3 raised to the third power multiplied by my g of x, which happens to be 10x. Now to clean this all up, I have y prime is going to be equal to 40x, 5x squared plus 3. Let's take a look at C. Again, I'm going to figure out what my ideal f of x is going to be. So my f of x, my outer function would be x raised to the 1/4, which is the same thing as a fourth root. Then f prime of x would be equal to 1/4 x minus a negative 3/4. Remember, I'm always subtracting off 1. Let me just erase this over here. And then my g of x is my inner function. So my g of x is going to be negative 3x to the 4th minus 2. That means g prime of x is going to be negative 12x to the 3rd. Y prime is going to be f prime of g of x, and then g prime of x. Y prime is going to be equal to 1/4. Now this x gets replaced with that, so it'll be negative 3x to the 4th minus 2 raised to the negative 3/4. Negative 3/4, I'll do that in black so you can see that is the derivative of f of x. And then I'm going to multiply it by my outer function, or my inner function derivative, is negative 12x to the 3rd. So when I clean this all up algebraically, the 4 and the 12 are reduced to negative 3x to the 3rd, and then I'm just going to put the negative 3x to the 4th minus 2 raised to the positive 3/4 in the denominator. All right, let's take a look at D. Again, I'm going to do my inner function, which is f of x. My outer function, f of x, which is x raised to the negative 2. F prime of x is going to be negative 2x raised to the negative 3 because we're always subtracting a power. My g of x will be my inner function, which is negative x to the 4th minus 3. G prime of x is going to be equal to negative 4x raised to the 3rd power. Y is equal to f prime of g of x multiplied by g prime of x. So y prime is going to be negative 2. My x gets replaced with g. So negative 4x to the 4th minus 3 raised to the negative 3 multiplied by the negative 4x to the 3rd. So y prime is going to be negative 8x raised to the 3rd divided by negative x raised to the 4th minus 3 all raised to the 3rd power. All right, so I'm just going to give you the answers for E and F. And well, actually, I'm going to talk about E first. So when I take a look at E, I can do this one by the quotient rule, and then I have to also use the chain rule. Or I can use this as the product rule and the chain rule. So I can write this as x raised to the 3rd plus 4 raised to the 5th power multiplied by 3x to the 4th minus 2 raised to the negative 1. If I do that, then this is my u and this is my v, and I'm going to do the product rule. Let me do v in blue. So y prime here is going to be u prime, which is 5x raised to the 3rd plus 4 raised to the 4th. The derivative of the inner function will be 3x squared multiplied by v, which is 3x to the 4th minus 2 raised to the negative 1. And then it's going to be plus, I'm going to have the derivative of my second function, which is v, so it's going to be negative 1, 3x to the 4th minus 2 raised to the negative 2, multiplied by the derivative of the inner function, which is going to be 12x cubed, multiplied by my first function, which was x cubed plus 4 raised to the 5th power. I can also do the quotient rule on this, but I still would have had to have used the chain rule. Personally, I'm a fan of product rule if I can do it. And that also explains why, when you're doing the quotient rule, why you end up with a negative right here. Why is it always a minus v prime u? Well, it's because if it's in the denominator, it's raised to the -1. -1 here, therefore, it makes sense that we now have a negative when you're using the quotient rule. Okay, so that was F. And then I'm just going to give you the answers to F and, or that was E. I'm just going to give you the answers to F and G, and I'll be happy to go over the algebraic cleanup or how we got the answers in class. Okay, so you can see here are the answers for F. This is not cleaned up algebraically. I end up with 4, and then I'd have this 5, so I'd have to clean that up, bring this in front, and then I have this. And then y prime for g is the derivative of this first function, which is all of this, multiplied by the second function. And then it's a derivative of the second function. All of this is a second function multiplied by the first function. Now on h and I, we're going to be having something slightly different because we're now introducing trig functions. So let me move this all up out of the way. So now let's look at some trig functions. So with the trig functions, once again, I want to figure out who is my inner function and who is my outer function. So I'm going to let, since they're using f here, I'm going to let h of x be my outer function, which is the sine of x. I'm going to have g of x still be my inner function, which is 2x to the third. H prime of x is going to be the cosine of x. G prime of x is going to be the 6x squared. F prime of x is going to be h prime of g of x multiplied by g prime of x, which in this case is going to be the cosine of, I'm going to put my original g of x in here, which is 2x to the third. That's my h prime evaluated at g of x. And then I'm going to multiply by my derivative of g of x, which is 6x squared. Now on I, I'm going to do it slightly different. I'm going to think of it as the angle. So I'm going to do it as u and then tangent of u. So if f of x is equal to the tangent of u, then f prime, or actually f prime of u would be equal to secant squared of u. U is, that was weird, u is equal to 5x to the third. That means u prime would be 15x squared. Y prime is the derivative of the trig function, which is secant squared of my angle, which was 5x to the third, multiplied by the derivative of my angle, which is 15x squared. So on y and k, or j and k, so again with j, this is the product rule. U is going to be equal to 2x to the 5th plus 3. U prime is going to give me 10x to the 4th. V is going to be the cosine of x squared. Now the angle is x squared. So then v prime would be the derivative of cosine, which is negative sine of the angle x squared, multiplied by the derivative of the angle, which is 2x. So then y prime is going to be my u prime, which is 10x to the 4th, multiplied by my v, which is the cosine of x squared. And then it's going to be plus my derivative of v, which is a negative sine x squared, multiplied by 2x, multiplied by u, which is 2x to the 5th plus 3. Now I do want to mention that you should make sure that you put on some parentheses here because if you don't, you're saying you have 2x multiplied by 2x to the fifth, and then you're going to add 3 to your final answer, which is not the same thing as when you have parentheses around it. So please note the parentheses. When you do your derivative test, it has to be spot on without the algebraic cleanup. So if you were to miss off this parenthesis, it would be incorrect. So pay attention to where your parentheses should be. If you are concerned about that, then write the 2x raised to the fifth power plus 3 in front of the sign x squared. All right, so now I'm going to look at my last one, and this time I'm not going to use the chain rule. I'm going to use the quotient rule. I prefer the, not chain rule, I prefer the product rule over the quotient rule, but this one I'm going to use the quotient rule. U is my numerator function, which is 2x squared minus 5. U prime is going to give me negative 4x. V is my denominator, which is the cosine of 2x to the third power. V prime using, and I know I have to use the chain rule because my angle is not x, will be negative sine of my angle multiplied by the derivative of my angle. So then y prime is going to be my numerator derivative, which is negative 4, multiplied by my denominator, which is the cosine of 2x cubed. Then it's going to be minus my denominator derivative, which is a negative, so negative makes it positive. And this time I'm going to write this as 6x squared first, multiplied by my numerator, which is negative 2x squared minus 5. I should probably put that in red so you can see that is the numerator. The numerator was negative 2x squared minus 5. My rest of my denominator derivative is the sine of 2x cubed. And the only reason I broke that up is so that you can see that I am making sure that I have parentheses in the right places and I have the multiplication correct. Remember about multiplication being correct. And then it's going to be over my denominator squared, which is the cosine of 2x cubed, the whole thing squared. Here's some more. Now, this one is slightly different on F. Actually, what I have going on F is I actually have 3 functions here. So I'm going to have h of x being in my most outer function, which is x to the third. And that's because I can write this as the sine of x raised to the fifth raised to the third power. My g of x would then be the sine of x, because that's the next function in. And then now I'm going to have to use something different. So I'm going to use r of x, which is my most inside function, which is x to the fifth. All right. My h prime of x is going to be 3x squared. My g prime of x is going to be the cosine of x. And then my r prime of x is going to be 5x squared, or 5x to the fourth. 5, a terrible 5. 5x to the fourth. 5x to the fourth. All right. So f prime of x is going to be h prime of g of r of x. Then it would be multiplied by g prime of r of x, and then it'd be finally be multiplied by r prime of x. Now notice how I go the outer function derivative, evaluated the inner functions, the next function in derivative, evaluated the inner functions, and then my last function, which is my most inner function derivative. What does this look like? This is going to be 3 of the sine of x to the fifth the quantity squared. That is h prime of g of r of x. Now I'm going to do the derivative of the next function in, which is sine. So this is going to be the cosine of, my next inner function is x to the 5th. So g prime of r of x, this is g prime of r of x. Now I have to do my most inner function, which is the r prime, which is 5x to the 4th. Of course, I would clean that up algebraically, but there it is where I have 3 functions that are nested. On my next one, my next example here on m, the only thing that's being squared is this thing, not the cosine, but the negative 3x squared plus 2. That's the thing that's being squared. So f prime of x is the derivative of cosine, which is the negative sign of negative 3x squared plus 2 squared. Now I'm ready to do the derivative of the next inner function. Well, the next inner function happens to be the squared. So this would be 2 negative 3x squared plus 2 raised to the 1. Notice I have not got to the most inner function. Well, my most inner function is 3x squared plus 2. So my most inner function would then be negative 6x. Here's my most inner function. Here is the middle function. And here is the outer function. So the most outer function is cosine. My most inner function is the negative 3x squared plus 2, and that middle function was the squared function. Let's take a look at my next example. On my next example, I'm going to have f prime of x. My outer function is, because I can write this as cosine of x, the quantity squared. My outer function is the squared function, so I'm going to have 2. And then inside I'm going to have the cosine of x raised to 1 power. Now I'm going to do the derivative of cosine, which is negative sine of x. So that is the derivative of the first function. Similarly, I can write this as 3 times the sine of x raised to the 3rd power. So my outer function is the cubed. So this will be plus 9 the sine of x squared. And then I'd multiply by my most inner function, which is sine, so that would be the cosine of x. Again, you can algebraically clean that up. If we can do first derivatives, we can absolutely do second derivatives with the chain rule. So y is equal to, my outer function is sine, so my derivative of the outer function is the cosine of my angle 3x squared, multiplied by the derivative of my angle. My angle is 3x squared, so its derivative would be 6x. This is y prime. Y double prime would be, now I've got u's and v's. This is u, and this is v. The derivative of u, the outer function is cosine, so it would be negative sine of my angle, multiplied by the derivative of that angle, and then multiplied by v, which is 6x. And then plus, now I'm going to have the derivative of v, which is just 6, multiplied by u, which is the cosine of 3x squared. So there is my second derivative. For b, I'm going to rewrite this as 3x to the 3rd plus 4x raised to the 1/2. Y prime, my outer function is the 1/2, so it would be 1/2 3x squared plus 4x raised to the negative 1/2, multiplied by my inner function derivative, which is 3x cubed plus 4x. Its derivative would be 9x squared plus 4. Now I have to do the uv stuff. This is u, and this is v. So the second derivative is going to be 1/2 the derivative of my outer function, which is negative 1/2 3x squared plus 4x. Now I'm going to subtract off another one, so negative 3/2. Still have to multiply by the inner function, which is going to be 6x plus 4. All right, so now I still have to multiply by v, which is 9x squared plus 4. Now I'm ready to do the derivative of my second function. So the derivative of my second function, or my v function, is 18x. And then it gets multiplied by my u, which is 1/2 3x squared plus 4x raised to the negative 1/2. So there is my second derivative. It got really large, really big, really fast. Okay, let's take a look at C. So again, my outer function, I'm going to rewrite this as the sine of the cosine of 2x raised to the 5th power. Y prime, my outer function is the 5th power, so this is going to be 5, the sine of 4, the cosine of 2x. The derivative of sine is cosine, so I have the cosine of the cosine of 2x. The derivative of the inner function, which is now cosine, so this is going to be negative sine of 2x, and then the most inner function multiplying by that 2x, which is just 2. This is the derivative of the outer function evaluated at the sine of cosine 2x. This is the derivative of the sine of the cosine of 2x. This is the derivative of the cosine of 2x, and this is the derivative of 2. Now, to do the second derivative, it's going to be the product rule twice, and I'm not going to put it in here, but you are more than welcome to ask about this in class, and I'd be happy to go over it in class. Now, we're asked to determine the equation of the lines tangent to the graph y is equal to x, square root of x minus x squared at these given points. So we know that when we're asked to find the tangent of lines, one of the first things we have to do is figure out what my x sub 1 and my x sub 2 is. Those are given to me, so I don't have to do that. So then what I need to do is just find my derivative. So y prime is equal to, this is u. The derivative of u is 1. This is v. So I'm going to write this as 5 minus x squared raised to the 1/2. Plus the derivative of v, which is 1/2, 5 minus x squared raised to the negative 1/2, multiplied by my inner function, which is 2x. Then I'm going to multiply that by my u, which was x. So I have y is equal to 5 minus x squared raised to the 1/2 plus, that should be a minus 2x. Should be a minus 2x. So it'll be a minus, not plus. So minus, now this 2 and this 2 will cancel, so I have a minus, and then I have an x and x squared. So I'm going to have x squared over 5 minus x squared raised to the 1/2. Now all I have to do is evaluate this, and this is y prime, is I need to evaluate y prime at x is equal to 1, and I need to evaluate y prime at x is equal to negative 2, because that's what they're asking me to do, is find the equation of the tangent line at those given points. So I'm going to put in 1, and I'm going to put in negative 2, into the y prime. Starting with the 1, I'm going to get 5 minus 4 raised to the 1/2 minus 1 over 5 minus, it's not 4, it's 5 minus 1. The answer is 4. It's 5 minus 1. 5 minus 1 raised to the 1/2. This gives me the square root of 4 minus 1 over the square root of 4, which is 2 minus 1/2, which gives me 1/2 or 3 over 2. So for my first point, my equation is y is equal to 3 over 2, x minus 1 plus 2. So here's my first answer, and that's for this ordered pair 1, 2. Now I'm going to put in negative 2. So this is going to be 5 minus a minus 2, so it's plus 2 raised to the 1/2, and then minus, I'm going to have negative 2 squared, so that's going to be 4 over 5 plus 2 raised to the 1/2, And I end up with the square root of 7 minus 4 over the square root of 7. So I need to make this a single fraction, so I'm going to multiply the first term by the square root of 7. And so what I'll end up with when I multiply the first term by the square root of 7, numerator and denominator, is I'm going to have 7 minus 4 over the square root of 7, which gives me 3 over the square root of 7. So my second answer using this ordered pair is going to be y is equal to 3 the square root of 7 x plus 2 minus 2. And those are my two answers. For this next example, we are going to assume that f is a differentiable function whose graph passes through the point 1, 4. So in other words, when I put in 1 for f of x, 4 comes out. So what that first part is telling me is f of 1 is 4. Now it's also telling me that g of x is f of x squared. So this is telling me it's a composition of functions where I'm going to call x squared, say, r of x. So I can write this as f of r of x. Well, r of x is equal to x squared. The tangent line of the graph at the point 1, 4 is 3x. This should be plus 1. So 3x plus 1. Now what is that telling me? That tells me that f prime of 1, when I evaluate this, it's going to be 3, because that's the slope of the equation of the tangent line. So I know when I do the evaluation of f of 1, it has to be 3. All right, so this stuff is all the things that are given to me. They're just not telling me it in this form, but that's what they're telling me that I have. So I'm going to actually go to the g prime first. G prime of x, based on the fact that this is f of r of x. This is going to be f prime of r of x, and then r prime of x. Well, the r prime of x is going to be easy. That's going to be x squared. So this is going to be f prime. Well, we don't know what the original function of f is, but we can kind of work it out. We know that when we take the derivative of the function and evaluate it at 1, I get 3 out. So one of the choices could be, and I want to do something fairly easy, in which when I have f of x, I'm going to get something here, and when I evaluate it at 1, I'm going to get a 4. So maybe x squared plus 1. Well, x squared plus 1 is going to give me x 1 plus 1, which is 2. That's not going to work because it's not going to give me 4. So, and the derivative wouldn't be 3. So let's try x cubed plus 3. Now this, let's see if the derivative works. F prime of x is going to be 3x squared. F prime of 1, that does give me 3, so that one works. Now if I do f of 1, well, this is going to be 1 plus 3, which is 4. Oh, and so I have this output. So what I think my function then is, my f function, a function that could work, is x cubed plus 3. Now, is this the only one that could work? No, this is not the only one that could work, but it's a nice one, right? It's a nice one. Okay, so I think I've got what f of x is, and I've decided that f of x, which will work for the constraints that are given to me, is I'm going to say f of x is going to give me x cubed plus 3. And that is a function that would work. So then my outer function derivative of this, the derivative of f of x, would be 3, and then it'd be my r of x, the quantity squared, and then multiplied by r prime, which would have been 2x. So this would have to have my inner function, which is x squared. This is my r of x, this is my r of x, this is my r of x, this is my r prime of x. So I think that's going to work for my r prime of x. Now, because g of 1, remember g is evaluated as f of x squared, so then g of x is f of x squared, which would be equal to x squared raised to the third power plus 3, which would be x power to power rule is 6 plus 3. So g of 1 would just be 1 to the 6th power plus 3, which is still 4. G of 1. Well, g of 1 would be, or g prime of 1, excuse me, would be 3 times 2, which is 6. So let's clean this up. This will be 6. X raised to the, I have 2 times 2 power rule, which gives me 4, plus 1 more is 5, is 6x to the 5th power. Now, let's see if that derivative works. If I take the derivative of x to the 6th, I do indeed get 6x to the 5th. So I evaluate this at 1, then I have 6, 1 raised to the 5th power, which is 6. Now, if we want to find the equation of the tangent line through this when x is equal to 1, my answer would be y is equal to that slope, which is 6, x minus, and it's still going to go through the same order pair, 1, 4, so 1 and then plus 4. So this is y is equal to 6x plus 2, and that is the equation of the tangent line for g that goes through the point 1, 4 when x is 1. In this example, we're going to look at the formula of the area of a circle where r is the radius of the circle. Suppose a circle is expanding at the bottom, and meaning that this circle is expanding, meaning that both the area and the radius are expanding. In other words, they're both changing. So suppose r is equal to 100 over t plus 7, the quantity squared, where t is in time. So find the rate at which the area is expanding. And they're also telling me to use the chain rule, d of a dt is equal to dA dr over dr dt. What the heck is that meaning? Well, basically, this is saying that I'm going to do the derivative of the outer function, which is the r squared, and then multiply by the derivative of the inner function, and this is my inner function. That's all that's asking me to do. The dA dt is using the chain rule to say the derivative of my outer function and then the derivative of my inner function with respect to time. And that's because the original function a is in terms of r only, but r is in terms of t, so I have to use this derivative of the chain rule to say the derivative of a with respect to t. So dA dt is going to be equal to, I'm just going to go down here and write that a is equal to pi r squared, which is equal to pi multiplied by, my replacement for r is 2 minus 100 over t plus 7, the quantity squared. This can be rewrote as pi, and that should be the quantity squared because it's r squared. Pi multiplied by 2 minus 100 t plus 7 raised to the negative 2, the quantity squared. Now, what I'm going to do, take off the extra parenthesis I don't need, is I'm going to do the derivative of my outer function first. My outer function is this. It is the squared part. So my outer function is going to be, I'm going to have the pi, I'm going to have the 2. Now I'm going to rewrite everything I underlined in blue exactly how I see it. So it's going to be 2 minus 100 t plus 7 raised to the negative 2, now raised to 1 power. Now I'm going to do the derivative of my inner function. This is my inner function. The derivative of 2 is 0. So I'm going to go ahead and write that. I'm going to have 0 minus, and then I have 100 as a multiplier, 100. The negative 2 is going to come down up front as a multiplier. I have t plus 7, and then because it is plus 7 raised to the negative 2, I am going to subtract 1 more, so I get negative 3. So that is my derivative of the inner function. Now I can clean that up algebraically, or I can just leave it, and I didn't have to write that 0, right here I just chose to. Now it's asking me to figure out how fast is the area expanding at the time 4 seconds. So that's asking me to do dA dt evaluated at t is equal to 4. So this is going to equal to 2 pi 2 minus 100 divided by 4 plus 7, the quantity squared. This is all going to be raised to the 1 power. And then my second grouping is going to be plus, so I have this minus and this minus is going to be plus. So plus 100 over 4 plus 7 raised to the 3rd power. And then whatever that is, my units, and this is important, is going to be how is the area? Well, the area is in units of inches. The area of a circle is inches squared with respect to time. So it's going to be my area of units for the unit area is inches squared with respect to time, which is seconds. And so whatever that ends up becoming, it's expanding at so many inches per second. And that's it for this video. It's a kind of a long one, but it covers a lot. I would recommend that you go through and watch any of the sticky bits that you're just like not completely getting. Watch it a couple of times, watch additional videos, and be sure to bring questions to class.